Welcome class to Professor Mendelssohn's house, where we're going to design a garage door opener for your second project. It is a beautiful sunny day. See, nice blue sky. There's the neighbor's house. There's my house. We are standing in my driveway and staring at my one-car garage. So I'm going to walk into the garage. Car, of course, is gone. You're staring at the electrical transformer box now that takes power in from the street. And we're going to get a view of the garage door and the garage door opener. And then I'm going to run the system, open the door, close the door, open the door, close the door, and then you'll get a sense for how the sub-mechanisms of this garage door opener work. First thing we have here in this box is a 1/4 horsepower motor. The box has a simple old-fashioned 30-year-old control board as well as a 1/4 horsepower motor. 1/4 horsepower motor, according to this nameplate, takes 6 amps of currents. It is plugged into the ceiling, which means it takes 120 volts and 60 hertz, going into a 15 amp circuit, drawing 6 amps of current. Pretty old-fashioned stuff. Actually has some potentiometers here to adjust the up and down forces, but we won't actually be getting into that because I don't really know how all the electronics inside works. So don't worry about that part. But what I'm going to do is just open and close the mechanism time and time again and repeat the basics of how the system works. So the system's open, door is closing. Most of the force on the door is applied with this chain system. There's a chain and it's attached to this bracket here, which I'll point out. Bracket, chain, sliding mechanism. There's a tensioning spring up here. And the basic idea is that as the motor rotates, there's a pulley up on top of this box that I will show you. It's right there. And as that gear motor, which is down in the box, rotates this very small sprocket, the chain rotates. As this chain rotates, what you'll see in a minute, is that this lever pulls on the door and pulls the door up and pulls the door ever and ever closer to the control box until the system says you have opened the door enough. And of course the door is open about 6 feet, enough to get even an SUV out and in. And when we go in the opposite direction to close the door, all we do is drive the chain in the opposite direction. Essentially, the bracket is going in the opposite direction, which wants to pull the door down. Now, you're probably wondering what this little yellow handle is, or excuse me, red handle is. Sometimes you can have a power outage and then you can't get out of your own garage. So if I were to pull on this mechanism, what you can see now is I can actually open the door with my left hand and slide it open and basically give the door the force that normally the motor is giving it. If I manually pull the door and shut it and reconnect my system, I should be able to have it go back to power on motion. Okay, so that's all that right handle's about. Now the slider has on it a mechanism that slides on this black track. You probably can see all the bearing grease. And that's because the slider itself has to slide along this eye-shaped metal track that's actually cut in a couple of sections and connected in the middle. And not only do we have that, let me close the door again so we can get a better view. But we also have a scenario where the chain is connected through the slider mechanism to a cable. And the cable goes up on a pulley up here. You can see that right there. And the cable goes around the other side. So when the door is closed, what you have on my right side is the cable, and on the left side is the chain. And then as the door opens, basically they trade places. As the door pulls up, the chain moves and the cable moves first. So let me just get you a top view of this sliding mechanism and a top view of the bracket. And right there is a little pulley for the cable, but not the chain, because the chain ends right here, and you never get the chain sliding on this pulley. In addition, all the way at the other side of the system, there is a sprocket for the chain, and that sprocket never engages this cable. Okay? In addition to this core system, we have a couple of brackets. And all these brackets are doing is they're fixed stationary brackets, which basically connect my slider mechanism to my garage door. They have a nice couple of bolts on them that go right into the garage door. And because there's a pretty large force, you can imagine these are not small bolts. They look, from the head, there's something like 1/4 inch, 5/16 size bolts. But I'll let you guys calculate that. And all you can see is as the door opens and the slider is moving across, all the force of that slider gets transmitted through this bracket to pull up the door. There's a couple of other small brackets, like this one here and this one here, that are not actually in the core drive mechanism. What they're really doing is holding the garage door together, because you see a garage door has to rotate, and you can't make a garage door out of a continuous section, because you'll never get it from the flat section that it's in and arc it around the turn here and get it to close. So in fact, a garage door is made of sections, and we'll go from my hand, go from here to there is one section, from here to there is another section, and there's another section. And all these little elements do, these small static brackets, is hold the garage door together. So it's basically a 6-foot door that's made up of 1, 2, 3, 4 panels. Each of those panels is about 1.5 feet high. And watch the door, because the door went from a flat and now the door is going through an arc as the door closes. So if you had a 6-foot solid section, you would never be able to get the door closed, because it would break when it was going through that turn in order to close. Now, we have a symmetric situation in that we do have rail guides here for small rollers that are connected on the left side of the door and on the right side of the door. And what those rollers have to do is, you can imagine if you're pulling on the door in the middle and you didn't have these rollers, the whole door would never open, because it would get cocked going from left to right. So what all of these roller systems do on the left side, and here is your track system for, call this one the right side roller, is your track system for the left side roller. What these rollers are doing is balancing the load on the left and right of the door, so that the door can balance and come up without too much friction and allow that 1/4 horsepower to open the door. So let's watch what happens on these roller mechanisms as the door opens. You can see that the roller is basically sliding in that metal track. And we have the top roller is in the top track, the second roller is in the lower track, third roller in the lower track, fourth roller in the roller track, and this bottom roller in the roller track. So that's what those rollers are doing. This is a fairly thick section of, I guess it's steel, kind of looks like galvanized steel, but I'll specify that. And by having these rollers go in tracks on the left And on the right side of the door, you basically balance all of that friction and the door opens smoothly. Now there's one little more fun fact that we're going to get into, is you have to be able to pull not only in the middle of the door, but you have to pull up on the left and right. And so what we have on the other side of this track is we do have a pulley assembly. And here is the bottom left of the door. There is a moving cable. There is a pulley. And that pulley is pulling a tensioning spring. And what the tensioning spring does is this. As the door, and let me just get it to open, opens, the pulley moves, and this extension spring collapses. Now what that does is it allows a force from that extension spring to be applied to the left and the right of the door, because there's one of these extension springs connected into the track, as I show you here on the left side of the door, and there's another tensioning spring that of course I'm not showing you on the opposite side of the door. As the door closes, the spring pulls out, and what that does is it de-accelerates the motion of the door closing, because you have got the motor now trying to close the door, but because you've got these two large tensioning springs, one on the left and one on the right, getting pulled out, and these tensioning springs are over 1 inch in diameter, and there's probably 100 coils, but I'll let you guys figure out the right number of coils. You got very large forces retarding the motion of the door to close, and that's what keeps your garage door from slamming shut. When a quarter horsepower motor is trying to shut the door, you've got tensioning springs on the left side saying, no, 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 don't shut the door down so fast. Open nice and slowly. And when we go to open the door, and of course when you open the door, you've got to overcome the force of gravity because you are pulling the door from this vertical position and bringing it up to this horizontal position. You can imagine the quarter horsepower motor is straining, but you see now these tensioning springs are compressing, which means all that potential energy in the tensioning spring actually helps you lift the door. So we have here in the picture a triangle shaped set of 3 brackets that attach the tensioning spring to the ceiling. You got a little steel cable here and a pulley, and the pulley is pulling on the tensioning spring. Here is your 2 loops of the tensioning spring, and there's a nice little bracket on the pulley that is right in the middle of these last 2 loops. That's actually was a homework problem. How many of these little loops do you need? And if you see where this actual cable is mounted, the cable actually mounts to a bracket, and that steel bracket is mounted directly to the door. And it's a similar mounting mechanism,